Okay, welcome to Integration by Parts, Day 2. Now, something feels a little different. I know the sentence up there maybe is scaring a few of you, but we're just going to get right into it just like we've done before. We're going to look at it. We've got a product, so we know that we can't use a simple use substitution, so we're going to have to do integration by parts. I can differentiate and integrate both of them, so it really doesn't matter which one I let be u or which one I let be dv. But since x squared gets smaller, I'm going to let that be the u. So that gives me x squared, so that means du is going to be 2x dx. My dv is going to be e to the x dx. And when you integrate that, you get e to the x plus c, of course, but we're going to wait on that. So now I'm going to rewrite my integral. It was x squared e to the x dx. That's going to equal u times v, so x squared e to the x, minus, and then duv, which is going to be 2x e to the x dx. Oh, that looks messy. Now, before, when I look at what I have in my integral, I could integrate that. But looking at what we have here now, I still can't integrate that with a simple u substitution. It is a product, so I'm going to have to do integration by parts again. I'm still going to choose the guy that gets smaller to be my u. So u is going to be 2x, which means du is going to be 2 dx. My dv is going to be e to the x dx again, which means v is going to be e to the x again. I need to make sure that I'm rewriting the first part because that is part of the integral of the original statement. And notice I have that minus there, so minus, and then I'm going to put this in parentheses. uv, so 2x e to the x, minus my integral 2 e to the x dx. Remember, all of that negative is coming through there. I'm going to go ahead and distribute that negative. So negative there, positive there, and now I get to go ahead and integrate. I have my x squared e to the x minus 2x e to the x plus that integral, which would be 2e to the x. Don't forget your plus c. So I had x squared times e to the x dx. I had to use integration by parts 2 times because even though that u part was getting smaller, it took 2 full times before I could get it to an integral that I could integrate. So when I'm looking at this guy right here, it's very similar to the same situation. X to the third is going to get smaller. That cosine is going to jockey back and forth between the two of them. So I would have to do integration by parts 3 separate times. Okay? Well, we don't want to do it 3 separate times. There's a method to the madness. Okay? And this is called the tabular method. So the tabular method to the rescue. Now, we're going to draw 3 different columns. Sign, and that's your positive, negative. What's u going to be? What's dv going to be? How many of these actual rows you're going to do depends on how fast it takes u to disappear. So I'm going to start off with this being my x cubed. So the derivative would be 3x squared. The derivative of that would be 6x. The derivative of that would be 6. The derivative of that would be 0. I have to have as many rows as it takes to get u, that notch, to be 0. That tells me how many times I'm going to have to integrate my sine of x? Well, if I integrate sine of x, that gives me negative cosine of x. The integral of negative cosine of x is negative sine of x. The integral of negative sine of x is cosine of x. The integral of cosine of x is sine of x. Alrighty, so u is driving how many of these rows we're going to have. What you want u to be, keep taking the derivative until you hit 0. Now the sine part, we start off positive, just like we do every day of our lives. We start off positive, and then things just kind of seem to alternate. We're happy, we're sad, we're happy, we're sad, we're happy, we're sad. Okay, so you're always going to start positive and then alternate from there. Okay. Then we do our rows. So when we're doing this, we're going to have positive x to the third times negative cosine of x. So that's going to be negative x to the third cosine of x. And then my next column is the next diagonal, minus 3x squared times negative sine, which is going to be plus 3x squared sine of x. Then the next one, positive 6x times cosine of x. And then the last, I'm going to have to do it in black, negative 6 times sine. And don't forget your plus c. So by using the tabular method, we don't have to do our integration separately, taking into mind that I need to distribute that negative through. Don't forget to write the first part. It can be quite tricky. But here, we're still taking the derivative as many times as we would have doing it as we went. We still have to integrate it just like we did it when we did the process as we went. The only difference is now everything is a little more organized. Everything kind of flows a little bit better. You're finding that integral and you're finding that pattern, so to speak. Finding that derivative, you keep going, getting smaller, and then your sign is alternating. Okay, so this would be your final answer. So the tabular method is used when you have to do integration by parts more than one time. And that's when you have an x to the second power or higher, and then you also have it multiplied by a sine cosine, or you have an e to the x. Those things don't get smaller, they just keep going. All right, so let's do that same process. Okay, we've got our sine, we've got our u, and we've got our dv. All right, so let's see how many times we're going to have to go through this. So u is going to be x squared. So I take the derivative, which is 2x, the derivative, which is 2, the derivative, which is 0. Okay. Now I'm going to take the dv, which is e to the x. I integrate it. Oh my goodness. We could do this all day. Whew, that was super easy. And then our signs, remember you always start off positive and then it gets negative, but then you go positive and then it gets negative. Okay, and then our first diagonal here. So positive x squared times e to the x, which is x squared e to the x. Ugh. Clearly my handwriting has not gotten any better. Okay, and then the next diagonal, negative 2x times e to the x, negative 2x e to the x. Try to make sure they can tell that's a power and not a multiplication there. And then plus 2 times e to the x. And don't forget your plus c. All right. Now, the last example, this one is a little bit trickier, but it's kind of fun in the same aspect. We're going to look at this in class so that we can have the fun together. But I want you to see if you can do our U, do the dv, see if you can figure out what's going to happen. Just a little hint, you're going to have to do integration by parts twice, and then something magical is going to happen. I'll see you in class.